Hello everyone, welcome back to the channel, and today we will start building our recipes chatbot. So let us try to design a basic architecture for what we are trying to build, and then we will take it on from there. So for our chatbot, first thing, as you would have guessed, is that we will need to have recipe data. Okay, so for having recipe data, for storing the data, we will need a database. And as we talked in the previous video, as we will be doing vector search on our data, so we will need a special database for this, and we will use PG vector. So this is a database from Postgres that supports vector chunking and embedding. So we will use PG vector for that. So we have the data in place now. Once we have the data in place, another major component would be our LLM, right? So we have to interact with some sort of LLM or large language model. For LLM, I think we have many options to use. Some famous ones being OpenAI, Gemini, okay, Grok. We also have Ollama, which is an open source model from Facebook. We have models like DeepSeek and others. So for this video, we will use Ollama because this is a free and open source model available to us, and we can also run it locally. So we'll not need to purchase any subscriptions and all. So for this, we will use Ollama LLM model. So our LLM is sorted here. After we have the LLM sorted, what we'll need is we will need a way or a layer that will interact with the user. Okay. So for this, we will build an API layer. Okay. And for building this API layer, we'll use Spring AI. We will see how that works in detail as we build the API layer. So what this API layer will do is, let's say the user sends in a prompt. API layer will accept that prompt, and then it will send the prompt, and then it will query our recipe data for relevant documents. Okay. As we have stored the relevant recipe data in our PG vector database, the relevant recipe data is returned here, and the API layer then collects this data and it would send it to the LLM with the enriched context here. Basically, this context is nothing but the relevant recipe data. So once this happens, the LLM processes our request and it gives us the correct response for the user's prompt. One more component that we will need here is we will need a way to ingest data into our PG vector database. So for ingestion, we will write a document injector that will accept PDFs or docs or text files, and that will be stored in the recipe data PG vector, and all the operations like chunking, embedding, all these operations will happen here. So this is like a basic flow of what we will be building. Now let's move into our IDE and start with building this chatbot. So let us start by setting up our database, that is Postgres vector or PG vector. So for that we'll use Docker. So make sure you have Docker installed in the system, and we'll start by saying docker run. We'll run it in detached mode, and we'll give it a name called Postgres vector. So this is for our local reference, and we'll use few environment variables like Postgres password. We'll give it Postgres, and we'll use Postgres DB. We'll give our database a name of recipe DB, and we'll map the port. So this basically maps your locally running 5432 port to the 5432 port inside the Docker container. So that port mapping is done, and then we'll specify that which image we want to pull and run. So this is our image name that we'll be using, /pg vector. So once you run this command, you will have something like this running up in your local Docker, right? So if you do a Docker PS here, right, you see that you will have something like this running on your local. If you have any port binding issues, you can change the local port 5432 to any other port, let's say 5433 or something. So with this, we'll have our PG vector local database up and running. To verify if the PG vector database is up and running, what we'll do is we'll try to log into the database and check. So we'll do my localhost. We'll use the user Postgres, and we'll use the DB that we created right now, that is recipe DB. Okay, and we'll do something like a generic query, maybe select version. Let's see if this works. So it will be, you will be prompted for your password which you entered just here. So we'll enter that. Now it's logged into the recipe DB, correct? So this is working fine. Let us try to run another command and see if that works. Yeah, so I think yeah. So this is the PG extension that we'll be using, and this is our vector embedding extension name. Now the next step from here would be to create a Spring Boot project, as we'll be using Spring AI for our project. So what we'll do is we'll go to Google Chrome and we'll go to start.spring.io. We'll start creating a new Spring Boot project. So for the group name, we'll give something like com.recipebot. Fill up all these details. We'll use Java 17. You can use anything. We'll add few dependencies here. So we'll add Spring Web. We'll add Postgres SQL, and we will add a dependency for the Ollama model as well. So Spring AI, basically it has built-in support for all the leading LLM service providers like OpenAI, Gemini, Ollama and all. So once we have filled these details, we'll generate the project and we will open it up in our favorite IDE. So I'm using IntelliJ here, you can use anything. Let me open up that project. So I've opened up the project in my IDE here. You can see a basic Spring Boot application has been created. So let us just try to run this Spring Boot application and see if everything is working fine as of now. So what we'll do here is first we'll do a maven clean install. It basically builds out the project, and now we'll do mvn Spring Boot run. So the usual running command for a Spring Boot application. So as you can see, the application has started on port 8080. So the next step is installing Ollama. So I'll use Homebrew to install the Ollama model locally first. So I'll do brew install Ollama, and I have already done it, so I won't do it again. But after doing this, Ollama will be successfully installed on your system, and the next step would be starting Ollama and pulling a model. So let me start that. I'll do Ollama serve, and it is starting the Ollama LLM model locally, and as you can see, it is trying to use the localhost ports for starting it up. And on another window, what I'll do is I'll pull a model that Ollama can start. So what I'll do is Ollama pull Llama 3.2. This is the name of the model. So this is similar to pulling a Docker image, and the model is pulled and the Ollama server has started, as you can see here. After this step, we'll go to our IDE and start making the changes for the RAG chatbot to work. So initially our aim will be to get a basic flow up and running, where we send a message to our RAG application or Spring AI middleware, and that the middleware reads or intercepts the requests and forwards those requests to the Ollama LLM server that is running locally. So for this, first we will need some environment properties. So what we'll do is we'll go to our properties file and we'll start adding in required stuff here. We'll add a server port, then we'll add few Ollama configurations here. Okay, Ollama configurations that are needed here are these three. So basically the local base URL on which our Ollama server is running, and the model that we want to run. This is basically the same model that we pulled from here, right? Llama 3.2. So we'll just write that, and this is the temperature control parameter for controlling the creativity of our model so that it does not create much hallucinations. Once we are done with all these Ollama configurations, what we'll do is we'll add few logging related configs here. So what we'll do is, so basically we have added the log levels for the Spring AI and for the Spring Web suite that we are going to use. After we do this, we just do a clean install once, and then we'll start with the basic code changes that are needed here. So what we'll do is we'll create a service first. So for creating a service in the core package, we'll create a new package service, and inside that we'll create a new class chat service. Okay, so the responsibility of this service would be to accept requests from the user and basically forward it to the Ollama model and then capture the response and send it to the controller. So let's write this basic Spring Boot service here. So we'll write the at service annotation here to so that Spring can manage this bean, and then we need a chat model. This chat model is provided by the Spring AI class, and this basically abstracts all our interactions with the LLM service providers. So this makes our life a lot easy. So we'll create a constructor here and we'll inject this dependency for chat model that we have created. So what we'll do is chat model, and we'll set the class level variable here. After we do this, what we'll do is we'll create a simple method to call the LLM. So we'll call this method chat, and this would have accept a message from the user, right? And what this will do is this will use the chat model, and it has a call method, and it will just pass the user message here, and whatever response is received from this method call is returned by this method. So this is a very simple service. Now let's create a simple controller class to expose our API. So we'll call it chat controller, and this chat controller will be a REST controller. So we'll add a REST controller annotation, and we'll also add a request mapping annotation here. So our APIs would look something like this /API/chat, and using this we will interact. We'll give a way to the user to interact. So what we'll do here is we'll be using our chat service that we created earlier. So we'll have that, and we'll inject into the constructor. We'll inject this dependency into the constructor. Now what we'll do is we want to give the users a way to chat with our LLM model, that is Ollama. We can create a post API that will hit this API route, and the request body would be something like this. They say, hey, can you provide the recipe for my grandmother's butter paneer? Okay, looks good. So let's build this. So what we'll do is we'll create a post mapping here. Okay, and this would return a map of string. So basically the response format would be something like user message and LLM response. So that's why we are saying it as a map of string and string. Now the name of the method we can give it as chat, basically following the REST API conventions, and inside this we can accept a request body, and inside the request body, as we'll be accepting the request in this format, so this is basically a map of string and string, and we'll call it request, and inside here what we'll do is, so the string user message would be the one that we extract from the request, right? So request dot get, we are expecting the parameter to be called message here, and then we use our chat service that we created here and the chat method to call and invoke our LLM model. So what we will say here is string response is equal to chat service dot chat, and we'll pass in the user message here. Okay, and when we return, we want to return a map of, so basically the user said this and the recipe bot says this. Makes sense, right? So basically we created this post API that will use our chat service and invoke the Ollama LLM that we have running locally. So let us now try to run this and we'll see how it goes. We are trying to build it now. So the build is successful. Now let's try to run it. So the server has started now. Let me go to Postman. In Postman, I have created a new collection here, or a new API request, and this is a post request. And inside this, I have just mentioned the localhost and the port on which our chatbot is running. So this is /API/chat, which is similar to what we have written in our REST controller here, and then we are just giving it a message. In the message we'll say, hey, can you provide me my grandmother's recipe for butter paneer. So let's hit it and see how it works. So as soon as we hit it, the request goes to our Spring AI server first, and then from here you will see that the request will go to our Ollama LLM model here, and it is calculating the response and providing it to the caller, which we will see here. As you can see, the request completes, correct? And then here you can see that I'd be happy to help you with recipe for the butter paneer. However, I have to clarify that without knowing your grandmother's specific recipe or cooking style, it might be challenging to provide an exact replica. So it provides a generic response, but it is lacking the exact data about my grandmother's butter paneer. So I think we have a basic setup ready now. You can try this out and try providing various prompts, and hopefully the local llama model would respond. And this is the way in which we have got a basic setup up and running. And in the next video we'll take it to the next step by augmenting this chatbot with our own custom data. Thank you, and I'll see you in the next video.